All right, so I'm going to talk about the Snazzy decompiler, as mentioned. We're going to go pretty quick because it's a lightning talk. So what are the topics of the day? First, we need to thank Cybershadow for the Snazzy demand that is there, because it's really cool, it's really snazzy, and it's going to be the mascot of SDC going forward. We're going to talk about SDC's internal a bit, very high-level overview, because it's a lightning talk, and then talk about SDFMT. So it's a modern implementation of a decompiler. There is an auto-generated lexer. Then there is a context where you can store a bunch of stuff in it, like names and location and stuff like that, parser. The semantic analysis is based on fiber. Everybody that have messed with semantic 1, 2, 3 in DMD knows why it could be useful. And it uses a JIT to do CTFE. The lexer, you basically you describe what you want it to do, and it generates a giant switch statement from hell that is literally, I think, like 70 kilobyte in size, something like that. You send your source code through that, and it finds all the tokens. It can optionally produce tokens for comments. That's very useful when you write tools that are not a compiler, but some other tools that needs to take comments into account. It can optionally decode on not strings, because same thing depending on, if you want to do look ahead, for instance, well, you don't need to decode strings. It goes faster. Very easy to modify, fast, robust, and usable as standalone tool, and can be used to make lexer for the languages. SDC use JSON as a configuration format, for instance, and all the JSON parsing is done with the same lexer, the same lexer generator. So then you have a context that's like a magic God object where you put stuff in it so that you can get handles that you use all over the place. It's especially useful for names. So compilers are full of strings that are the same all the time, like your variable names or function names or stuff like that. You're going to reuse them all over the place. And the compiler, for the most part, don't care what those strings are. It cares that they are the same, and it can look it up in hash table to do symbol lookups and stuff like that. The names are for humans. So the compiler can store the string in the context, give you an unique identifier, and you use it everywhere in the compiler. It keeps also track of sources, so sources of code, like files and mixins and stuff like that. Keep track of origin and whatnot. And most importantly, keeps track of locations. So as a result, it can give you a 32-bit handle for locations. With 2 of them, 64-bit, you can track a range in your source code. It's so small that you can keep track of the location of pretty much everything through the whole process, which is very useful when you want to output error messages, debug information, this kind of stuff. And it does so, well, there are a few details on the algorithm, but it doesn't really matter for lightning talk. Okay. So then semantic analysis is done in a way fairly different of most compiler, because D has fairly unique features, mostly compile time features, stuff like CTFE. If you do enum something equals some function call, then the function needs to be completely semantically analyzed so that you can run it at compile time for the enum to be analyzed. And as a result, you have an implicit dependency graph in your source code between all your symbols. It's not explicit. You cannot discover it ahead of time, so you can build giant complex machinery, or you can have a fiber per symbol and have the scheduler schedule the fiber, and if you need another symbol to be resolved, you ask the scheduler, hey, I need that other symbol, and the scheduler schedule the other fibers, and it all works like magic. 1 minute? Okay, I'm not going to do SDFMT then, that's fine. So it uses a JIT to do CTFE. Why? Because it already knows how to do codegen. It's a compiler, so it might as well do it for CTFE as well. The code is far simpler that way because it's the same code path now. You get dramatic performance gain for complex CTFA. For very trivial ones, you can do them via constant folding, so it doesn't matter. And so for this intermediate one, it's a bit slower. And in the same vein, you get SD unit that's going to run the unit test on your module, and that's going to be it, right? We're not going to talk about SFNT, all right?
So in what state is SDC? When are we going to be able to use it? And then I have a follow-up question.
So there are already tools that come out of FDC, like SDFMT, that you can use today. It's used in production at Symmetry, for instance. For SDC itself, it's a bit of a it's a bit of a difficult situation because for any program that basically uses Phobos, you need to use like every single D feature under the sun. So you need to be like 99% compatible, and it's not quite there. Most of the difficult features are done, but there is just a long tail of small stuff that needs to be nailed as well. But it can already compile non-trivial stuff. It compiles its own runtime, and there is a garbage collector in there, and a synchronization library and all of that. There is also a crypto library that I wrote that it can compile. There are non-trivial piece of code that it can compile, but it's just not like the 99% there that it needs to be to compile anything that uses Phobos.
And how close are you? Sorry, how close are you following the release schedule for DMD, for example? Because DMD gets a lot of features every now and then. So.
Yeah, nowhere close to following DMD.
All right, that's all time for questions. Thank you, Amaury.
So good afternoon, everyone. The whole point of this is just to give you an idea of where to look. And basically, since this is only 5 minutes long, don't expect me to go into any detail. I will not. Generally, you should think, in my meager opinion, based on what I've done before, in many instances, not doing this in process would have been better. So I would say choose wisely when doing this. With .NET DLLs are just DLLs in name only. They're not DLLs as we know them from C# or from C++ and D and so on. So be careful mixing them. This also kind of requires use of Visual Studio, legacy Visual Studio, and so on. So let's move on quickly. Just calling C# is pretty simple. I'll show 3 ways that I've done it. One is there's a add-in to Visual Studio called unmanaged exports. Basically, that tampers with the Eyal and makes the thing callable by pretty much anything. Suddenly, you can have your C# code consumed by Visual Basic in Excel if you want. Another way to do this is to use a C++ shim with C++ CLI. The nice thing about this method is that you can sit in Visual D and debug through 3 different languages, if that sort of thing turns you on. So that's kind of nice. Now, unlike the other one, this is completely official. There's no code tampering going on here. So there's nothing monkeyed with, so everything here is basically stock. There's nothing here that'll void the warranty. And then last and certainly least, mono. So you can get into mono using derelict. Okay, you got to watch it. Derelict sometimes gets a little stale with newer versions, but I found that a derelict generally works reasonably well. I heard that mono isn't as fast, and I can't tell. So my mental picture of the .NET garbage collector is just like the snake room from Raiders of the Lost Ark. Everything's always moving around and so on. So basically, that's the problem here. So once you've called the function, you still need to bring your, anything but a simple scalar argument is easily called. If you want to bring your string or array or something better over, you need to basically do some kind of marshalling. And so then you have to deal with the .NET garbage collector here. So needless to say, dueling garbage collectors. Does anybody here remember dueling banjos? Okay, dueling garbage collectors is not a pretty melody. So my approach has always been to let the Wookiee win, meaning, so I'll ask the .NET garbage collector to keep a little bit of memory kind of stationary so I can copy in and out of it at my leisure. So that's really the second point here. So once you've been able to call C#, you need to now move your data back and forth. Marshalling is I don't know, I never liked that word somehow. It reminds me too much of police. So, but, casual function calls, no problem. The second you need to bring over anything of any complexity, you need to marshal that. Now, the C# to C++ marshalling has been pretty straightforward, but nothing's moving around, so that works. Not so true with D. So the marshalling strategy I tried, which of course can go for some improvement, is simply to do a bit of a tango. So you first have your thing you want to move to from D to C sharp. You basically serialize that with the serialization of your choice. I used JSON, it's called .NET with the length and of what you want. You copy it over once it's allocated, and then basically call the function, get the result back, same sort of serialization, but you use the .NET garbage collector to keep a little bit of your result, however big or small it can be, reserved so nothing happens to it. So in summary, use one of 3 different methods to call the function, pin the variables you need, and do the tango. Have a look at my, my project here. I will eventually copy all the stuff over, all bits of information. So thanks for listening.
Did you measure the performance overhead of calling the FFI, calling the C# function from D?
No, I didn't. The fact is that I could do, it's like the dog walking on its hind legs, that it does it at all.
Would you suggest using this binding in production, calling C# from D?
I would suggest think carefully. It depends on really the size of the thing, the number of DLLs. If you have 1 or 2 DLLs you're dealing with, I would say yes, no problem. It's a question of complexity, because one thing, if you're trying to copy something over that has a lot of DLLs, that'll cause a lot of name pollution. You need to have those DLLs present wherever your executable is. That executable may need a configuration file for .NET, and there are all sorts of complications that go with it. You got to try it. In general, we found this to work pretty well under production. But on the other hand, we had some fairly nightmarish conditions. Having said that, if you have a small number of DLLs you have to deal with, I think I would say yes, but your mileage may vary. Give it a try.
Thank you.
Yeah, I personally run .NET executable and DLLs. It's a lot less friction that way. Anyway, we need to move on.
All right. So when I was learning D, I was kind of surprised by the fact that there are some keywords in magic positions. I'm used to case and default opening a statement and struct and class opening a declaration, but in some locations you had go to case and go to default, or object equals class, and it kind of looked wrong, but it's kind of something that D does sometimes, and yeah, you can do it. So let's talk about return, which is another one of those statements. We're all familiar with it as the return statement. But in D, you also have return scope, a lifetime annotation that says that if the input string is stack allocated, then the compiler needs to know for safe code that the return value is also stack allocated. And arguably, it shouldn't allow it according to the spec, but you can omit the scope to still infer return scope. And if you have a struct member function, even if there's no parameter list, there's always this hidden parameter, this, that's used to access the struct fields. And if you want attributes to apply to that hidden parameter, like const or return, you put it after the parameter list, which kind of looks weird. Similar to member functions, there's also delegates, which if you take the address of a member function, you get a delegate. And you can also have a nested function, which also has a hidden pointer that instead of pointing to struct fields, it points to the stack frame and the local variables on the stack frame. And you can omit the delegate keyword for shorter literals and also add return to there. Let's go back to our identity function. Did you know you can call a parameter string? That's because string is not actually a built-in keyword in D, but an alias that's automatically imported in all your code. And so after you declare the variable, string will from now on shadow that type and refer to the variable instead. Return is a keyword, so you cannot do that same trick. But identifiers in D allow universal alphas, and Unicode has this nice list of confusables where letters from other alphabets look very similar to Latin letters. Do you know where I'm going with this? This compiles. Thank you.
So you're done?
Yep.
All right.
Yeah, now, I'm happy to leave this up for another minute. What do you guys think? Yeah, well, we've clearly got questions.
I got insane working on DIP 1000 bugs. That's why I did this.
Will we be seeing you in The Hague regarding this?
I think Manu asked, why did you do this? You want to answer the question?
Well, I got it saying use it. Yeah. Can you send me the
It's
the
just
code
like
snippet?
I work on div 1000 bugs, and the syntax is very confusing, so I know how like people are confused with return, return ref, scope return, return scope, so I thought it would be fun to kind of highlight it.
Yeah. Can you send the code snippet?
Hmm?
Can you send the code snippet?
Okay, I will do.
What does your code do? The return.
Nothing, it just declares some kind of nested function with a parameter and returns it, yeah.
Okay, I only have 5 minutes and we have a bunch of slides to go through, so let's just go through. Basically, next release, we will have first an aesthetic change, colored output. We now have warnings properly displaying, so you can like quickly see what's broken, and you can quickly differentiate all your log lines. This also especially helps with the included compiler errors like deprecations. You now know where they actually come from, because you can actually see which package is building before that with a nice green building thing. Error improvements. We've got improvements to the JSON parsing for dub-selections.json, dub.json, still upcoming, and dub-settings.json. It will now show you if you're using keys which are not actually valid. Like they wouldn't actually do anything and you may have just typoed. Right now we just dump a list of all the possible keys, but we're still working on making this error message better and more readable. Performance improvements, we are working right now on reducing file system access, because the more packages you get right now, the more packages you have on your PC, the slower dub gets, and we definitely want to avoid that. So first of all, fewer reads to the file system. Right now it goes through all the packages, reading all of them 3 times on every dub command you run. And we want to change that so it actually only reads the dependencies you need. Consistency improvements. Some commands have now a little bit changed. We now have just dub : sub package, which is now equal to dub run sub package. So much for consistency. You could just run dub before. Now you can also dub sub package. And dub build config unit test, dub build with config unit test is the same now as dub test. So you can actually like define your own configuration thingies and make it work the same as dub test. We have dub upgrade -s now. It's recursive upgrading. In case you have worked with submodules in your dub packages and sometimes had like broken dependencies because they weren't updating, now we have dub upgrade -s, which does it recursively for all the things. I would just recommend you always use dub upgrade -s when you have sub packages. There will also be a warning now when you have sub packages and are not using -s, because it's the thing you always want to use actually. There's a new sub command basically in development. It's dub select. It shows you a full dependency tree of all your dependencies in your project. It's not yet merged, so we don't know if it will be in the next release, but it will definitely come in somewhere in the future. And it shows for you, for example, mismatching dependencies, so you actually know where these dependency errors come from. You can also use this tool to force a specific selection. So this is what you would use then to edit your dub-selections.json file instead of like manually editing it, because we're also planning to add hashes to the selections file soon. We have CTFE coverage now, so built with CUF CTFE and unit test covered CTFE, and it will actually like show the functions that would have previously been completely empty because they were never called. This new build type now inserts the coverage equals CTFE flag to the compiler, so you actually know what CTFE is calling. We have DLL support, which you might not know, but using target type dynamic library, you can create DLLs, which you can just pack with your dependency, and this basically works now also on Linux and on Windows, but on Windows only with LDC. If you use DMD, it's still broken. So Walter, if you could fix that, it's not emitting like module info and stuff. We've got inject source files. You can basically now create files that inject custom code into your dependee. So you can make a package that registers, that runs code in the context of your dependee. So in the dependency, you have this file, this hook file, which can import the variables thing, which is actually in another module. Copy files, you can copy files into the dependees scope. So basically, if you have like a dependency with files in it, you can use copy files and it will appear in the actual caller. Also dpath configuration things for installation, you can now choose
10 seconds.
you can now choose where it's stored. And last thing, Git dependencies, you might not have known about those, but they have been in for a while. You can use Git URLs with the exact commit hash to actually.
The alarm's gone off, but it hasn't sounded. That's your time, man.
You mentioned the support for Git dependencies. When a Git dependency requires authentication, like a private repository in GitHub, is it possible to access it?
I'm not quite sure about that. If you can put the username and the password in the URL, it's probably possible. It's basically just running the git clone command. So basically, if that works, then it should work everywhere.
Why didn't you set the -s as default if that's what you should use all the time for the upgrade path?
For the dub upgrade -s, it's like also upgrading the selections file in all the submodules. And we had like a discussion on the pull request. We maybe would have wanted to make it the default, but it could have broken backwards compatibility on some packages actually expecting special selections. So we did not do that yet.
Sorry, very quick. But dub.stl or dub.json?
I prefer dub.stl.
Okay, so I'm just going to present some charts which kind of show like the overall activity that has been on the DMD repos and bug fixes. I'm not going to go into details on why the charts are like this. I'm just going to show them and just do some maybe technical analysis on the charts. So these are the DMD PRs. So as you can see, since DMD has been listed on GitHub in 2011, we have had a bullish activity, and then we entered bear territory. Also, you can see what's interesting that, so we have like with blue, the number of PRs that were created. With red, if the PRs that were created in a specific year were closed, then you can see that like for most of the points, it matches exactly. So most of the PRs have been closed. And with yellow, we have the total number of closed PRs. So for example, in this year, we didn't close all of the bugs that have been created in that certain year. And maybe here we've fixed more bugs from the past. So essentially, it seems that the activity closely follows. So right now we have like 200 open PRs in DMD, which are mostly coming from the back. Now we can see that the trend line is up, so we don't take into account 2022 because it's still an ongoing year, and I expect that will be somewhere around here at the end of the year. And we can see that this pattern is closely followed, right? So we have 4 years in which we enter in bearish territory, but then we kind of recover. So I expect that in 2023 will be somewhere around here, right? Okay, next, D runtime also has had a major support line here, but it has broken into bearish territory for some time, and since D runtime has been merged into DMD, we expect that it's probably going to go bankrupt. So. Phobos, on the other hand, also has seen bullish territory, has been in bullish territory, but for some time it's been going down. This could also be seen as maybe Phobos is being stabilized, or maybe we are lacking contributors. I don't know because I didn't really research that, but anyway, I wouldn't suggest being bullish on Phobos right now. Now let's take a look on how the bugs look. So I just took this chart from Bugzilla. Apparently Bugzilla can generate some stats. So this is the total number of bugs that has been reported with the new label across the years. So we can see that we've had an increase of reports up until 2016, 2017, where actually we've started to normalize. So I expect that we are going to get down in the following years, or maybe just have a few years where this is like a flat, but then it should probably go down because I guess like most of the bugs have already been reported, that since we're stabilizing, we're not going to have too many new features, then yeah, we basically have all of the bugs. However, you can see that like the number of fixed bugs, so with red we have like the total number of fixed bugs, whereas with the other colors we have basically the number of bugs that have been closed with a specific attribute. So we can see that resolved is like we fixed is this line that it's continually growing and has been constantly growing. So if we take a look back at the number of issues that are being reported, we can see that we have constantly been fixing bugs. So if these trends continue to this way, then we're going to have like less bugs. So yeah, I don't have any more charts, but if I still have some time, I'm going to maybe make use of it and to tell you that we have like this summer school that we usually do, and we've created some materials which are all on GitHub. There are like materials for beginner D programmers. I didn't put a link here, but I'll probably put it, I don't know, on the forums. So if you want to maybe drop by and give us some feedback, that would be great. Thanks.
So I see on that graph that, you know, the fixed bug line is trading up, and on the previous one, the number of bugs is tapering off. So do you think that if these trends continue in the future, we're going to see a negative number of bugs?
That would be great. That means that the language writes itself somehow, right?
Can I trade options in the number of bugs?
You can try.
Should I sell all my new bugs or buy new ones?
You should probably buy some puts.
Is this good for crypto?
We couldn't establish any relationship between like the crypto market and the DMD stock.
At Funkwerk, I'm responsible for filing debugs, and as a result, when my colleagues see me coming in the room with, hey, look at this cool thing, they know to go for cover. But I don't think of them as bugs. I think of them as magic tricks. Let's see some magic. Maybe need to put down the mic a lot. Okay, this is newspaper style. So in newspaper style, we first write what we need and then we implement it. So I want to print the type of something. What is the thing? It is something that has an identity template. Okay, what's the identity template? It's just TST. What's the type? It's just bar.
You're going to need to pick your microphone up.
Okay, do it again, because it was so beautiful. Now we get a different type. What? All right, next one. This one is called Cataclysm. Let's see what's in it. Here you go. Okay. This is called Cataclysm. Why is it called Cataclysm? It's Hello World. Yeah, ignore that. Hello world, it's very harmless. It's very, very harmless. Let's add two very basic flags to print dependencies. Let's use an older compiler because it's maybe a bit less crashy, and let's see what happens with that. By the way, the graph on the right is the memory usage of my computer. It's currently at 16 gigabytes free. It's going to go very far down. Let's leave that running because I don't have that much time. Let's just keep that in mind. All right, next one. Magic JSON value. We have a function that sets a field in the JSON value to 2. All right, that's very sensible. Now we have a constant JSON value. Const means we cannot modify it, right? Oh, that's weird, but surely it can't work at runtime, right? What? Okay, next. This one's called daemon. There's a thing called daemon threads. That sounds scary. Let's do the most unscary thing. Oh, hey, by the way, it finished with a crash. Very nice. Let's do the most unscary thing we can probably imagine that uses daemon threads. It's this file. It just starts a daemon thread and it quits immediately because the program exits. I should have prepared for this better. All right, there we go. Does it work? Yeah, it works, but does it work if I run it 1,000 times? Let's leave that running for a bit and let's look at the last one. Oh yeah, it's a finish ad sec for it. No wait, this is a different one, hang on. I've lost track of everything. Hang on. While true. Oh, because I was doing exit. Yeah, I was doing exit instead of break, so it closed the shell. Yeah, just trust me that that crashed. We're going to see it again in a bit. All right, so this is the first. This one is already fixed. So we have true, and we repeat true infinitely often, and this should all be true, right? It's infinity. Now in the current compiler, this will work, so I'm going to use a slightly older one. Hang on, that's weird. What? Oh, by the way, that crashes. Daemon threads crashes. And repeatedly, like after about 1,000 times. This is why we never exit a program without calling exit anymore. Thank you.
Well, I have a comment in that possibly one of the best bugs in the Bugzilla is you can actually mutably modify a template declaration by instantiating it. So that's fun.
It's not really related to D in any way. It's a personal project, but I think it's fun. Basically, what is it? We believe it's the IDE of the future. Not yet, but in the future. It's also a language. It's statically typed. It's purely functional. It's kind of inspired by Haskell. And a passion project that we founded, me and Yair, about 10 years ago. What's new in Lambdu? It's structural and projectional. What does it all mean? So I'll show with the demo. OK, so let's do an example. Like, we all know that functional programming languages are basically programs to write factorial, right? That's what they're used for. So I'll start with that, like factorial of, let's say, let it choose the variable name. Then I check if it's 0, right? And then, oh, it's now num. It's renamed based on the type. So now I'll be basically, the base case is 1, and the recursive case, up, caps lock, now -1. Now I can basically activate factorial for, let's say, 5. I'll apply it. And there you go. You have basically like a spreadsheet. You see all of the sub-expression values, and you can basically page in and see what happened during each invocation. Let's use maybe, like in a spreadsheet, maybe I edit this base case to 2, and immediately see what happens. Yeah, the result updates immediately. Let's do the second thing that functional programming languages know how to do, which is Fibonacci sequence. Oh, sorry, I should have. So how do you generate the Fibonacci sequence efficiently? I don't want to use the exponential solution that blows up in 20 or so. I want to use the efficient one. So I'll use a pair that basically goes over the sequence. I'll use a function called iterate. It's inspired by the iterate function in the library of Haskell. You take an initial value and the function, this is the initial value, and this is a function to generate the next value, and you can generate an infinite sequence of values. So we'll generate the infinite Fibonacci sequence. So my value will be, oh, sorry. My value will be a tuple, but a named one, car0 next 1. Now notice that type inference that's going on all the time understood that the type of the function takes the pair as a parameter. So it unpacks the pair for me here. It also notices that the result, the hole that represents the result, requires, it's supposed to be the same kind of tuple. So I can just press enter to complete the tuple. Car is next. Let's n, c plus n. And I've got the infinite list of the Fibonacci sequence. Now, let's say I want to take 10 elements. Notice how everything realigned because the screen is much smaller than I expected, but it realigns automatically. And then I do a 2 array so I can actually see the result. So you see, this is indeed the Fibonacci sequence, but it's a bunch of pairs. And I don't want a pair. I want to have just the numbers themselves. So I can just highlight the expression generating the sequence, add a dot map to it, and now I can see the map takes a lambda that also unpacks. I choose car, and as you see now, I have the actual Fibonacci sequence. Now to make this reusable, I can highlight the sequence, press extract. it goes one scope higher, another extract goes another scope higher,
1 minute left.
another extract, and now I can call this is the real Fibonacci sequence. And notice how it collides. So it generated suffixes for the names. This is just a Fibonacci test. Now, yesterday, I think Walter talked about programming in different internationalizations and languages. So here in Lambdu, the code is not really text. It looks like text, but it's structural. So I can just switch to Espanol, switch to Italiano. So now the same code is in Italian. So this was actually contributed, I don't know Italian, but it's the corrento is porissimo, and I have no idea how to pronounce this stuff. So, prossimo. So yeah, so if I move to Hebrew, it's all right to left now. And you can also basically switch back to English, and then I can go and disable some sugars. For example, maybe I disable the apply sugar so you can see all applies are actually applies of records, but they're just displayed nicely as applies with keyword arguments.
And that's time. That's your name pronounced. I forgot your name.
What's that implemented in?
We wrote it in Haskell. Like my favorite systems programming language is D, but my favorite high-level applications programming language is Haskell right now. So we use Haskell and OpenGL for the graphics.
What is usage in production or any app or something?
Well, I wouldn't recommend it for production just yet. My partner, Yair, who founded the project with me, he's actually using it for real stuff. He likes acro yoga, and he manages the web app. The backend is written in Lambdu. So you can do real stuff, but in 5 minutes I can't really show. But it's not really ready for production.
So there's a common question you may have asked yourself. If you append to an array, how many times do you get reallocations and copying the existing elements? And looking at this 10 million elements, it's around 23 or 24 you might expect from conventional growth factors. But in fact, and you can write a program to test for it, you can add the element, check for the capacity change. If your array's capacity changed, your array needed to allocate memory, but then you will find it sometimes pointer didn't change. This is because the D runtime is so smart. Instead of insisting on a growth factor, it will look at the next bytes. If they are not used in that page of memory, the growth factor will just use the capacity, however many bytes are there, elements are there. So if you run that program, you will realize that there are tons of in-place expansions in the memory, and no matter what, how many threads you run this test yourself, you will be surprised. It's very efficient. And you see, instead of 23, 24, you get only 18. And there are some growth factors which grow just by 1 sometimes. So my good friend and colleague Yannis, instead of using my imperative style for loop, he wanted to do the same exact test with functional style. He started with iota n. In a map function, he appended an element to the array, and then he returned a data information of the pointer and the capacity pair of the array at that time. And then he created a sliding window on the source, and sliding window is just looking at elements, in this case 2 elements at a time, shifting. And because the elements of what slide is looking at are not constant elements, map is generating all the elements. Okay, now I'm going down to my place. Now there, for that one, the 2 slides will execute the map twice. And in the end, look at the bottom, instead of getting n number of elements in your array, you get 2n minus 1 elements. And then he came to me, Yannis came to me, saying, how come this is happening? Because it works in Rust. So we looked at Rust implementation. They have a tuple window, which uses a hard-coded 4-element cache in there, which I know has been increased to the hard-coded 12 today. And Yannis was lucky to have 2 being less than 4. So I don't know how Rust works, whether they can support more than 4. I decided to come up with a cache design for elements, because this is not the only case this happened. In the past, I know people complained about map executing functions multiple times. So imagine we have a source range where the source is some elements. We can copy the elements, pop them out of the source, and put them into a cache. And these 0, 1, 2 are not really values. They are talking about the index of the element. And then we can have some ranges, logical ranges looking into the cache. instead of the source, so the sliding window of 2 will not repeat the execution anymore because the execution happens bringing the source down to the cache. Now you may have some empty ranges here, and you may attempt to make a dot front on an empty range, which is not an error. You can, these guys can support front on an empty range. What will happen is it will just say, wait a minute, do I have a front element? I look empty, cache looks empty, but the original source is not. So it will go ahead and pop one more element, and now both the empty range and all its friends sharing gain one more element. So they're sharing the original cache altogether. So this is the idea. There's a single cache owned by many ranges. So this is what happens behind the scenes. When you call the cached range algorithm, it returns a dynamically allocated cached object, which calls a member function of it, makeSlice, and returns one range. And makeSlice itself returns a ref-counted slice object, so that all the ranges are reference counted owning the cache. And going back to Yannis's code, if you add cached in there, everything works and everything is efficient. Now you get length equals n. The interesting part is now your cached is both a forward range, and that's exactly what slide needed, and it's also a random access range. It could be a bidirectional range, but I did not implement it. The end. And then you need to take care of some dropping the unused elements. If nobody is using them, there's some algorithm that drops it. Thank you. Going back. I need more time on this to release it, not released yet. And there's also a cache which doesn't work because it caches one.
Stop. Let somebody ask you a question about that. Lead them into a question and then I don't care.
Hey, Ali, how much time do you need to complete this?
2 more weeks, probably, just to be sure.
Cool.
Yeah.
I hear there was something that didn't work. Tell me more about that.
Yes, so dropping the unused elements from the beginning of the cache is important, otherwise you will consume the entire memory for an infinite range, even though you don't care, right? So there I had an opportune moment to drop those elements, and that's when the array length equals capacity. So the cache elements length equals capacity means I'm about to copy my cached elements somewhere, now it's the time to drop them. But it turns out with my algorithm, length and capacity would always be 1. So that's why I put a reserve there to change that behavior. Now I don't drop all the time, but more efficiently. And that's why I don't release this yet. There are such weird cases there I haven't thought it through.
Yeah, I've just I decided to come out of the closet. I've actually been using D since 2008. So I'm originally I'm an ASIC designer. But I have programmed all my life. So the last 4 years I've just doing software. And I like to do to solve my hardware problem with software. And in ASIC design, one of the problems is mask generation, and in the digital circuit you have place and route tools. In analog circuits you need mask generators. In modern EDA tools you often use some manual process or something called a GDIS2 compiler, which is actually, GDIS2 is just a file format for layouts. And this is typical what you have. You have a transistor, and then you need to do something like this, where you have a gate and a drain and source, and so on. And there's actually a very nice data structure for doing this, very simple, because all layouts is actually 90 degrees. So you can make a data structure where you have 4 pointers, you have an X coordinate, and then you have 4 pointers, so you always point to the next rectangle. So you can just ask this polygon for the X and Y coordinates. So it's a very easy way to traverse a data structure in layout. So this means you can do all what you need in with this algorithm called a corner stitching algorithm, and you can do and or XOR size and all this what you need. and device generators, DRC checks, ESC, and routers, and so on. So in 2002, we started to implement this algorithm in C++ and rendering netlist and parsers and so on, but it turns out to be very ugly and unstable. So yeah, we had to find a fix, and then we found D, and we started to port this to D1 and use the DMD script, and we actually also ported some of the DMD to partly support HTML5 or ECMAScript script. So, and we also ported AND-LR, whatever. And then, yeah, we also wrapped DMD script to run PSpice and some part of 6s. This is a parallel simulator. And in around 2012, we then ported to D2, and that's actually it. So.
That's quite a long time using D. I mean, are you happy with how it turned out?
Yeah, I'm actually very happy with D2. It's I was thinking in the beginning, I was actually writing D1 as a Java-like, right? And I didn't really. I was just, and actually AND-LR was very easy to port to D because I just used it. I just nearly just passed it around. So yeah, and then and a good thing with the tool was actually that we used DMD script instead of a virtual machine. So everything was running in D. It was much easier to handle.
So this was your company started using D in 2008?
Yeah.
Not just you.
Yeah.
So I wonder then if Funkwerk still has the title of the first D shop. We'll have to find that out. We didn't know about anybody else back then except Funkwerk and Sociomantic.
Yeah, but it was an internal tool. It wasn't. It was just to solve internal problem. We didn't sell it. It was just.
Yeah, that's fine. That's fine. Yeah. Internal's perfectly cromulent use.
It doesn't have to be user friendly. It does have to work.
Well, the good news, I guess, is that is the end of the lightning talk. So thank you, everyone.